Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA 2021 Combined Science Physics Paper 1 Higher Tier. This is a trilogy paper or the Combined Science paper. In this paper, there's going to be 4 topics that is tested. Sorry, that's a mistake. Let me remove that. So, energy, electricity, particle model of matter, and the atomic structure. It's has 6 questions and it is out of 70 marks, and the paper is 1 hour and 15 minutes long. So question number 1. Question number 1 is on the topic of electricity. Figure 1 shows a mobile phone with its battery removed. A student measured the potential difference across the battery and then put the battery into the place. This is what is the equation linking current I, potential difference V, and resistance R? Tick one box. So the equation that links current, potential difference, and resistance is V equals IR. If you look in the equation sheet, you should find this equation, right, where potential difference equals the current multiplied by the resistance. Next question, 1.2. The current in the electronic circuit in the mobile phone was 0.1 amps. So the current is 0.12 amps. That's the I. The potential difference across the battery is 3.9 volts. That's the V. Calculate resistance, which is R, on the electronic circuit in the mobile phone. So using the equation that we've just stated above, V equals IR. The potential difference is 3.9 equals the current is 0.12 multiplied by the resistance. Rearranging the equation, resistance equals 3.9 divided by 0.12, and that gives you an answer of 32.5 ohms. So 32.5 ohms. Now, looking at the marks, it was 3 marks. So you get 1 mark for writing the correct equation and substituting the values. Another mark for rearranging the values, and the third mark for writing the correct answer. Now, if you didn't write all of them and if you just simply wrote down the correct answer, you'll still get all 3 marks for the correct answer. Next question. Write down the equation that links energy equals power, energy, power, and time. So again, looking in the equation sheet, you'll find that energy equals the power multiplied by the time. We change the color, right? Question 1.4. The battery was fully charged when it was put into the mobile phone. The battery discharged when the mobile phone was switched on. The average power output of the battery as it discharged was 0.46 watts. That's the power. The time taken to fully discharge the battery was 2500 minutes, which is the time. Calculate the energy transferred by the battery. So again, using the equation that we just stated, energy, which is E, so energy transferred is the power multiplied by the time. Now the time that we have to use here has to be in seconds. The value that they have given is in minutes, so that needs to be converted to seconds. How do you convert that? You multiply that by 60. So 2500 multiplied by 60 gives you 150,000 seconds. So the energy transferred is the power, which is 0.46 multiplied by 150,000. That gives you an answer of 69,000 joules. So 69,000. Again, looking at the marks available, it's 3 marks. So 1 mark for the conversion, 1 mark for the substitution, 1 mark for the correct answer, or you get 3 marks for the correct answer without showing any working. But I would always recommend that you show the working. Next question. The mobile phone includes a sensor to monitor the temperature of the battery. Figure 2 shows the circuit symbol for a component used in the sensor. What component does the circuit symbol shown in figure 2 represent? So you can see that this rectangular shape is mainly for a resistor. So if it was just simply rectangular shape like this, that would be a fixed resistor. Now this one has a line going across. It's not an arrow, it's a line going across, and then a horizontal line as well. Now this circuit symbol is for a thermistor. Now if it showed like this, again a rectangular shape but with an arrow, that's a variable resistor. So there's mainly 3 types of resistors that you can be tested on. So you'll have to remember the circuit symbols and the names. Remember, a thermistor is a resistor that works depending on the temperature. So the following question, the temperature of the component in figure 2 increases. So the temperature is increasing. The potential difference across a component remains constant. So they're keeping the potential difference constant. Explain what happens to the current in the component. Now think about the equation V equals IR. If this is constant, right, let me write it as K. Right, let me properly write that as a K. So V equals IR. If V is a constant, and if the temperature is increasing, what happens to the current? So you have to find out what is happening to the resistance when the temperature is increasing. Now, when the temperature increases, what happens to the resistance in the component? The resistance decreases. Now this is something that you will have to remember for a thermistor. What happens to the resistance when the temperature increases? The resistance decreases as temperature increases. Now if the resistance is decreasing here, what happens to the current? In order to keep the potential difference constant, the current has to decrease so that this value remains constant. So the second mark is to say, so the current will increase. Those 2 bullet points would actually give you the 2 marks for this question. That brings us to the end of question number 1. I will see you in question number 2.